So the momentum of the Mini adds to the momentum of the Ram before the collision, and those are the two vectors we're looking at. Now we know that the Mini, let's move this back over. All right, we know that the Mini actually, after the collision, the Mini flies to the left. And that vector, we know what it is, right? Because we know how fast the Mini is flying away. So let's calculate that. Momentum of Mini after is going to be, it's going to have a magnitude to the left, right? And it's going to be 1132 times 30 in magnitude, right? So the magnitude of the momentum, that's what those vertical lines mean, is going to be 1132 times 30. And let's figure out what that is. So clear that. 1132 times 30 gives me 33,960. 30, that was cute. 33,960. Is that what it was? Yeah. Okay. So 33,960 to the left. So this vector is our momentum of the Mini after the collision. So the momentum of the Mini after the collision plus the momentum. Okay, so 43,582 plus 33,960. Okay, so if I draw this correctly, this one isn't this long, right? This is 134,714 for the Ram. So this looks a little better. I'm pretty sure that the 43,000 and the 34,000 aren't going to add up. So this vector to the left that I'm adding, so probably draw it a little shorter than that, right? Okay. The vector in red, this is the momentum of the Mini afterwards, right? And the total momentum before has to equal the total momentum after. So these two vectors added, or the blue ones have to add up to equal the two vectors after the collision. So let's say that the Ram is moving to the left. Let's say we suggest that that is correct. We take the Mini and we add it to the Ram, right? So the two red vectors, actually all the vectors would need to add to 0. Is that correct? The Mini and the Ram before, that's the blue. So the Mini going this way, the Ram going this way. Those vectors add up to this right here. And the Mini in the end is going this way. And I'm thinking the Ram is going this way as well. So that the two red vectors add up to equal the two blue vectors. Okay? So I think we got it here. This is 33,960, right? And it looks like we can figure this one out. It's going to be, the momentum's got to be, let's see here, 33,960. Okay, so I'm going to have to do 134,714 minus 43,582, right? Sorry, I'm doing this wrong. Oh no, I'm okay. Minus 33,960. And that should give me the momentum of the ram in the end, right? So let's see what that is. And then after, this is the ram after. So the ram's momentum's got to be 134,714 minus 43,582 minus 33,960. That's 57,172. All right. So 57,000. What was it again? 172, right? That's cute. 172. And since it's momentum, it's kg meter per second. And these are all momentum. Okay? So now that we have the momentum of the ram after, we know the ram's going to be moving to the left. So the mini bounces to the left, and the ram is still moving to the left. This number has to equal the mass of the ram. So 57,172 has to equal, what's the mass of the ram again? Let's see if I can remember that. It's 5443. So 5443, 5443 times the speed of the ram, so mass times velocity. We already know the velocity is to the left. So the speed's going to be 57,172 divided by 5443. And that's going to be in meters per second. So let's see what we get. 57,172, it's already there, divided by 5443, and that gives me 10.5, so that's 10.5 meters per second, and that's the speed of ram after the collision. We could add the words to the left, and we've identified the direction the ram's moving. That was a cool problem. That was pretty hard. Thanks for watching. Have a good day.